Hello and welcome to the ELECTRO-MASTER channel. In this video, I will show you how to repair a Sharp R360S microwave oven. If you're dealing with a similar issue or simply passionate about electronic repairs, this tutorial will be very helpful for you. Don't forget to like this video if you found it useful, leave a comment with your questions, and of course, subscribe to my channel for more useful tutorials. Every like and comment helps me a lot and motivates me to keep posting content. Thank you so much for your support. To begin diagnosing the Sharp R360S microwave oven, the first step is to check its power supply. I connect the appliance to a 230V AC power source and observe whether the display turns on and if the buttons or control panel respond to commands. If there are no signs of operation, I can check the outlet fuse and the continuity of the power cord. The internal fuses of the microwave, which may have blown for safety reasons. The control board and electronic components that might be preventing proper operation. This initial test helps determine whether the issue is related to power supply problems or if a more complex fault within the internal circuit needs to be investigated. I observe that the appliance does not power on and does not respond to commands from the control panel, indicating a possible issue in the power supply circuit or the control board. To diagnose the fault, I will check the following. Power cord continuity. Using a multimeter, I will ensure that voltage reaches the internal terminals of the appliance. Internal fuses. Most microwave ovens are equipped with protective fuses, main fuse and high voltage fuse. If these are blown, the appliance will not receive power. EMI filter and input rectifier. A faulty filter can interrupt power supply to the control board. Control board. If voltage reaches the board but it does not power on, there may be faults in the auxiliary transformer, bridge rectifier, or voltage regulators. Based on the results of these checks, I will determine the exact cause of the malfunction and proceed with the repair. On the first measurement, I identified that the fuse is faulty, which explains the lack of power to the microwave oven. To confirm, I tested the fuse using a multimeter set to continuity mode. I found that it was open, meaning it had blown either due to overcurrent, short circuit or overload, or as a protective measure against a fault in the internal circuit. Before replacing the fuse, I will perform additional checks to determine the cause of the failure. To check for a short circuit in the power supply, I use a multimeter in ohmmeter mode and measure the resistance at the power cord terminals. A very low value indicates a possible short circuit. As I observe, everything is okay. Next, I will check the control panel, specifically the power supply to the control board. The first step is to ensure that voltage is reaching the control board. I will measure the input voltage at the power supply terminals to check if it provides the necessary current. If there is no voltage or it is incorrect, I will inspect the power supply for any defective components, such as burnt capacitors or faulty diodes. I will also check the safety fuses on the control board for any interruptions. If the power supply is functioning correctly, I will continue to analyze the rest of the electronic components of the control panel. I carefully checked the electronic board, but I didn't find anything that would explain the damage to the fuse in the power circuit, such as defective components or a short circuit. After this inspection, I concluded that there are no visible issues on the control board that could cause this malfunction. Therefore, I reinstalled the electronic board, ensuring that all connections are correctly made and that there are no loose or broken contacts. The next step will be replacing the fuse and testing the appliance's functionality. For testing purposes, I will replace the 12-amp fuse with a smaller value, specifically 3.15 amps, as a precautionary measure. This will allow the fuse to blow faster in case there is a defect, thus protecting the other internal components of the microwave and preventing further damage. It is important to note that this approach is temporary for testing the appliance's functionality. In case of a malfunction, the 3.15 amp fuse will react quicker than the 12-amp fuse, limiting the risk of greater damage. I recommend following the same procedure if you encounter similar issues. As can be seen, the microwave seems to be responding to commands. Therefore, I will perform a test using a cup of water to check if the magnetron is emitting waves and if it's functioning properly. I will test the water to see if it heats up correctly, which would confirm that the magnetron is generating the necessary microwaves. If the water heats up, it means the magnetron is working and the microwave is still operational. The water is hot, which indicates that the magnetron is emitting waves and is functioning correctly. This confirms that the microwave is producing the necessary microwaves to heat the food, and the heating process is working as expected. Therefore, we can consider that the magnetron is in good condition and the microwave is operational. I have purchased a 12-amp fuse, according to the original specifications of the microwave. This is the correct value recommended by the manufacturer to ensure the protection of the power circuit and to prevent damage in case of overloads. I advise you to do the same and use a fuse of the same value to maintain the safety and optimal performance of the appliance. I have reassembled the appliance, and as you can see, it is functional. The microwave responds correctly to commands and heats the water, confirming that the issue has been resolved. If you enjoyed this video, don't forget to like, leave a comment and subscribe to the channel for more tutorials. Your support means a lot to me, and comments and feedback are always welcome. Thank you for watching, and I'll see you in the next video.